So I'm going to jump right in, and I've got a few topics here. Let's get that going. So DataGumbo, kind of a strange name. Either you like it or I hate it, but you're never going to forget it probably. So I'll talk a little bit about where we come from, who's DataGumbo, and then smart contracts in practice. It's, yes, there's blockchain, but it's really not about the blockchain. It's about value. So we'll talk about that, and the value of the smart contracts actually is in the networks, right? The connections between companies, because we don't just do things between two companies. Usually there's a whole bunch that come together to do big things, like in construction and certainly in mining. And then I'll take a few minutes to talk about what it takes. Is this a big lift? Does this take a lot of effort? What's involved in actually getting started, and then open it up for questions. Okay, introduction to DataGumbo. And I'll begin with our origin story. So we didn't start out in the mining sector. We started out in oil and gas. Our founders are upstream oil and gas, full careers, and really we began as a company as a automated data platform to pull in IoT data from all the disparate original equipment manufacturers on a drilling rig. Andrew Bruce, our CEO, was given the charge to try to automate a drilling platform, and figured if you could automate the landing of something on the moon or Mars, why can't you do that with a drill bit? That was the basis behind it, and that's really the origin of the name of the company, is pulling disparate sources of data from different equipment manufacturers and different data sources, figure out a way to how to make sense of it so that you could use it to control the drilling operations. And so Andrew had been working on that for a while, but still not getting a lot of traction in the market. And he was in a meeting with one of the global operators in oil and gas. And that's why you've got the picture here. And I don't know how familiar you are with oil and gas and the exploration and well construction, but they do, they drill using pipes, and they connect a section of pipe, and then they spin it, drives the drill bit, drive it down, and then disconnect, add another section of pipe, and drive it down. And they call those drill pipe connections. And this particular global operator does about 2.5 million drill pipe connections a year. And they were like, if we could just get our, service companies, our, contracting partners to work with us to reduce that drill pipe connection time from 6 minutes to 5 minutes, it's worth about $250 million. And we're more than happy to, to share that with them. But we can't get a single contractor to agree, to work with us on that. And Andrew's like, I know those guys. I know the CEO over at this contractor that you're working with. Mind if I go talk to them? And he did. And the story from the contractor was, of course, we could reduce it from 6 to 5 minutes, but to be honest, we don't trust them. We just think they'll use, that incentive on the drill pipe connection times to drive down our day rate and then find some reason not to pay us the incentive. And so Andrew came back with that feedback, and they had the discussion, and he said, because he'd been looking at blockchain, and he said, I've got this IoT platform. I know the exact 6 points of data that I can verify that cycle time. What if I just, take that data, use a smart contract to perform the calculations, the validation, and calculate the incentive, and then store all of that information, on a blockchain, in a block, immutably, and so that it can be shared to both parties. And in a meeting with both companies, he said, you think that would work? And they said, yes. And that's where DataGumbo as a blockchain company essentially was born, was out of that. So from that origin story, we moved forward, and initially, Andrew and William Fox, our chief product officer, looked at all of the existing, blockchain technologies were out there, and came to the conclusion that we needed to build our own from scratch, because it was an industrial application, and we needed to be able to store large amounts of data and information on chain. So what we ended up putting together, and we call it GumboNet, but it's essentially combining 3 technologies. So he's taken that IoT data platform to pull data in from all kinds of different sources. It doesn't really matter as long as it's digital. We pull it in and into a standard data model. Then the smart contract is pointing to that, to that data model, pulling in the required data to identify what we call trigger events. Something's happened. And then essentially, usually there's units of measure in some form of measurement of quantities or volumes or services provided or whatever, and then applies the appropriate, commercial terms, penalties, incentives, modifiers, and creates, then the smart contract will create a block and store it on the blockchain. So what you see here is really those three technologies together, and it's all about the data and not big data. We're about specific data. It's what we've ended up developing. This is a private permissioned network. It's really a neutral, independent platform. It's not governed by consortiums. And the smart contracts and all of their transactions are transparent to all the contractual, the contractual parties, with everything being stored on chain. So think of it more like a business to business network, and the companies decide who do they connect with, and they connect using smart contracts. Okay, so you've got that technology, that GumboNet. How does it get applied, and where does it add value? Because it's not about the blockchain; it's really about the value. And so where we started was actually looking to take the pain out of the invoicing and payment process. Not sure if the numbers are as bad in the mining sector as they are in oil and gas, but DSO, or daily sales outstanding metrics, in the 70 to 100 days is not abnormal for a typical service provider in the upstream oil and gas sector. And part of the challenge is what you see on screen here. This is a typical service performed, invoice debt preparation, submittal, reconciliation process, and eventually leading to payment. There are just 16 steps here. What we typically find when we get to both companies and how their processes work, usually this is between 30 and 40 steps, with the majority of those requiring some human touch, some human intervention, somebody looking at something, clicking a screen, pulling a drop down or whatever. It's a very laborious process, and it leads to those long payment cycles. So what we do by connecting the IoT platform with a smart contract and then the distributed ledger saying, here's the truth, and making it transparent to everybody, we're able to take this cycle time down from the point of the transaction to actually being able to pay, invoice and pay, can essentially go down to 1 to 2 days. Right, from 60, 70, 90 days. It just depends on where you are today. And a lot will come back and say, well, what about, we got 30-day payment terms? Well, you can pay in 30 days, but in terms of verifying the transactions, say, okay, this is ready for payment, you can perform that in as little as 2 to 3 days. And so from a service provider perspective, we see, from the time of providing service to being able to generate the invoice, dropping from 30 to 45 days down to, like I just said, 1 to 2. And then obviously from the payment, can go within 1 to 2 days, or if it takes, a bit longer for the payment terms, then it can go out to 30, 45, 60, whatever those agreed are. But what we find when we do this is the discussion begins to shift. Well, what about fast pay discounts? Certainly, the cost of capital for an operator or mining company versus the service company is vastly different. And in the construction sector and the oil and gas sector, the service providers, the cost of capital to fund the financing cost is, in the double digits in terms of percentage rates. And for the operators, the stronger balance sheets tend to be low. And so they're looking at more like fast pay discounts and things like that, and having better control of cash flow. So where does that lead us? If you step back and look at kind of where we are and why we do business the way we do, in our daily lives, in what we call B2C, or business to customer, it's become much more automated. It's basically swipe and go. Whether you're doing a ride share, or staying at a place in Airbnb, or buying groceries, or filling up your car with fuel, we swipe and go, and all the records of that transaction are available to us, right? That verify the quantities, the pricing, the route I took, the timestamps of the start and the finish, and what it actually cost. So why in the business world are we doing things the way we did 100 years ago when we had literally paper ledgers? And that's the value that we're trying to get initially, and that's where DataGumbo got its start. So if you look in the offshore side of the world, we've done time value studies in terms of applying the smart contracts, and we're finding that the drilling engineers are spending up to 30 to 40% of their time around contract management and handling invoice related issues. In the construction sector, the numbers are the same across the total installed project cost. So whether it's 30, 40% or just 10% or even 5%, it's a big number. Okay, smart contracts in practice. I'm going to give 2 practical examples here and then list out the different templates that we have and currently developed and in our library. Thought we'd start with one that's closer to a real life mining example. This is actually active for us right now. For those of you that may be familiar with the upstream business and what they call fracking, is that a large volume of sand is used in that to once the fracking is done, the cracking of the shale, then sand is pumped in at high pressures to hold those cracks open to allow the oil and gas to escape. So oil and gas companies have formed relationships with mining companies that are mining sand in various regions. And so this particular smart contract is pretty straightforward, right? So the operator's making a call, hey, we need some, they call it proppant, we need some sand, we're getting ready to begin fracking operations. And so they make the call, the dispatch is done. And so at the loading site at the mine, the sand is loaded, with the timestamps, the weight or the volume, the mesh, its location. And then the sand is delivered to the site. And if there's GPS data associated with that on the truck, so we know the route, we know how long it took, we know the distance that was driven, it arrives at site. There may be belt scales there or other measures of volume, checking the mesh, and receiving essentially the material there at the site. And then the smart contract, we consume that data, right, from all of those different sources to perform the verification. In this case, it's a two-way match. You're getting information from the mining company saying this is what we provided, and then you're matching that against, well, here's what we received, here's the volumes, the mesh, and so forth. And if those were within a certain tolerance that the 2 parties agreed to, that's an approved transaction. Then we can apply the appropriate pricing. If there was demurrage or some other modifier applied to it, it gets applied per the contract. And then that transaction gets recorded as a block on the blockchain. And then whatever the parties have agreed to in terms of the invoicing, the invoice process will go and pick up all of those blocks and create an invoice and deliver it however they want it. If they want it in a PDF sent to a payables email address, or they want it as a data package, it's a JSON file into a ERP system, can do that as well, however the parties need it. And maybe the mining company wants it, the charges accounted for this way against these codes. The operator may want it against a different code, right? Maybe a cost center for the well. And so we're able to position and organize that data in whatever party, the way that they need it. Next example is a bit more complicated and probably closer to some of the more complex drilling operations. This is for what we call mining operations. We call it integrated drilling and well services. The concept is basically the same as what we just saw with the sand, but it's more complex. There's a mix of services, rental tools, as well as product being delivered. This is to offshore operations, so delivery is occurring in a variety of different ways. In this particular case, we did what's called personnel on board. So the labor that was being taken out to the platform to work, they were delivered via helicopter. And what we were getting was essentially the data from the helicopter on who was on board and when were they delivered. We're mapping that to what their rate what their role is, what their rate is, and making that personnel on board calculation. The same for the delivery and consumption of chemicals that was done during operations. And then there's a lot of rental tools that are used. And so being able to know the real tools that are on board, when they're used, the start and stop times, and then automate all those calculations. And so this went really well, actually better than the operator and the service company expected. And currently this operator is in the process of deploying a standard smart contract for all of their drilling operations in the North Sea. There's 15 different sites, 3 different service providers, and we're incorporating the entire contract, which is about a 650-page contract with over 30 different, commercial conditions. So when we can get the data, the smart contract is really good at consuming the data, making the calculations consistently and quickly in an automated way that's verifiable back to the source. So it's auditable and it's transparent. So where else are we seeing this getting applied? And so I mentioned, we're developing, think of smart contracts almost like an app store. They're sort of applications that run on top of the platform that, produce the blocks that get stored in the blockchain. So we're developing a contract library. And, for DataGumbo, our interest is, yes, we're doing these now because we have to, but our hope is that, we teach others how to develop, their own apps or their own smart contracts to run on the platform. And so we actually don't even retain the IP for these. We make it available. And if there are derivative contracts that start with our code and you want to develop your own, we're more than happy to support you in doing that. So obviously, we got our start in what I call the transport side. So everything from moving wastewater to drill core, diesel fuel, chemicals, sand, final products like lubricants. You would think that would be pretty straightforward, but it's actually challenging because of temperature differentials between where it was packaged up and where it was received. It expands or contracts, and so there's disputes over volumes. Things like that occur, and so they really want to use smart contracts and IoT data to make that a lot easier to do. Getting more and more into services type contracts, whether it's the provision of use of small tools or personal protection equipment, actually like through vending machines and other types of releases and automating those, rental tools and equipment. Obviously, the integrated drilling well services, we've actually started on some of the maintenance services, call-off maintenance. We did earlier, about a year ago, proposal to do maintenance turnaround for mining operations in Australia. They decided not to go forward with that, wanted to build it themselves, but certainly the application in that space. Replacement parts and materials, really good application for smart contracts. So that's really what I would call the touchless transaction side of things. But we're also looking at and provide value, if you think about across the value chain, provenance related to track and trace. And we've got several use cases that we're in the process of developing for process pipe. If you think about it, in a refinery, there's pipe that may have to meet a certain spec, and this operator wants to trace it back, not all the way back to the ores it got mined, but actually to the production of the steel. If it's stainless steel, is it to the spec where the material search for that? And then it gets moved to to rolled into pipe, and then it gets cut into process pipe and all the welded inspections and things like that. All of those certifications and inspection reports, as they move down that value chain, getting stored on chain. So it's not, PDFs of PDFs of PDFs. And it's a real challenge in that particular sector. Similarly for equipment, and then we're also getting into 3D printing for additive manufacturing materials. And if you think about being able to certify, the material that's going into the printed, let's say a tool or a piece of equipment, it's absolutely crucial, as well as the testing of that, both virtually and then the actual testing once the product is produced. And then finally, we're getting heavily involved because we're capturing all of this data related to commercial activity and operations. We're finding that it can be pivoted and used for ESG reporting, and in particularly greenhouse gas emissions. And, obviously scopes 1, but also scope 2. We've got a project right now doing for across a pipeline network and all the electricity being provided, the emission sources, and calculating the scope 2 emissions. And then because we're connecting, all the different participants across the supply chain, we're able to do scope 3. So for example, if I'm the operator in that sand example, we know the truck, we know the exact distance that it was traveled, the timestamps. We're able to calculate the emissions per that location for that particular asset. And just like, there was an invoice for that load delivered to the site, there is a greenhouse gas emissions calculations for scope 3 emissions for that delivery that we also capture. And then, so where's the value? Related to the touchless transactions, that's where most of our value calculations and business cases are done. I won't go through these in detail, but I can just say what we're seeing in terms of, if you compare the total contract value, we're seeing savings in the 5 to 10% of the contract value on both the operator side and the buyer side, as well as the seller side. It varies a bit, obviously, depending on the business and the use case and so on. But 5 to 10% savings of contract value is a pretty sizable savings. And this was actually recognized. It's public that Equinor is an investor in DataGumbo and a backer, and has provided some of our initial smart contract proof of concept opportunities. And here's some actual real savings that were realized on one of their drilling platforms. Drilling and production platform, excuse me. Okay, so that's a specific smart contract. Let me get into where's the real value. The real value is not in a single contract. And what we find is, we implement that first contract and both parties are like, oh, wow, it works. So now what do we do, right? And so we don't just have one contract, and we don't just have one, counterparty for one contract. We may have, 5 different service companies that were using that contract. And we literally have hundreds or thousands of contracts in our, that are used in our business across our, portfolio of products and services that we need to, do whatever we do. So this is really where, I think, DataGumbo may be different in the market in terms of it's a platform. It's the existing platform, and it's intended to be a business-to-business network. So, across the, the mining sector, there's all sorts of different players in terms of, from the exploration and evaluation of the, the underground assets and, what are the, what's going to be mined out of that, the design and the construction of the mine itself, and then, you get into operations. Those 3 steps are not dissimilar from what you see in upstream oil and gas. And then there's all these other players involved with that, from the, the regulatory side, being able to, we've done compulsory regulatory reporting, at these well sites. If they do, there's so many flare events within a certain period of time, they have to pay a fine and issue a report to the EPA in the United States. So you're able to automate that, right? So you're not having to have a human being do that kind of stuff. Insurance, obviously the processing, refining, fabrication, components of that, the maintenance of those facilities. We're seeing a huge pickup in the waste management side of things, particularly around provenance of that, not just the commercial side of it. And then across all this entire network, obviously there are ESG concerns and greenhouse gas emissions. So what have we done in terms of looking at it more from like a platform perspective? So sort of think of it like almost like rideshare, kind of like Uber or Airbnb, combined with a LinkedIn type approach. So what you see here is some, just some screenshots out of the platform or the companies coming into how they get connected, inviting someone to connect. And essentially what that does is there's an owner of a ledger, they're inviting participants to, to that ledger, and then a contract gets applied, right? So we're going to connect, we're going to use this contract to interact between us. And then once that contract gets, initiated on the ledger, then you can begin transacting between the 2 parties. So really the value is in the network, right? It's not really about the blockchain, it's about all of those connections. And so if you step back and look, beyond just the single contract, and let's say across a total value chain, and I, picked an example that we're working live right now, and this is more in the LNG sector. So it's moving all the way from the production of the natural gas, getting it transported to a facility, liquefaction facility that compresses it into liquefied natural gas, and then that gets moved to a location that needs it. So we're seeing a lot of that in the U.S. where we've got fairly lower cost natural gas. It gets compressed into LNG and then gets shipped to other markets, whether that's China or Europe, where it gets regassed and then used to typically drive power generation. So across all of these, there's these three things that I just talked about. There's that transaction burden, right, and the toughness of actually between all of these companies and the service providers that are working in each of these steps of the value chain. It's costing a lot of money, whether it's 10% or 20%. There's hidden cost in those transactions, and if you're able to automate those and verify at the transaction level, not 30, 60 days later when an invoice comes in, it's much smoother and faster and requires less effort to do. ESG we're seeing is becoming a bigger and bigger concern. If you're in Europe, it's a bit nearer to you because you're being required to not what they call greenwash. You have to actually have measurements and validation and verification behind your data and your claims. And so ESG, we see that as becoming more and more important, and actually a really good application of smart contracts and distributed ledgers, because those emission sources are across all kinds of different things, and being able to point to those different data sources, have them be verifiable, auditable, and then recorded immutably in a blockchain, gives some credibility and does away with the greenwashing concern. And then lastly, the track and trace, right? And so across that value chain, so one of the big concerns in the oil and gas sector is what's called embedded emissions, right? And embedded emissions are the emissions associated with the burning of the product. And so as an example, you can almost follow it here. If you were to look at ultra low sulfur diesel that goes into shipping, right? And in maritime. And so that ultra low sulfur diesel actually came out of the ground at some point as oil. It went into a refinery, right? And got turned into ultra low sulfur diesel through those processes, and then moved through a distribution network, eventually ending up at a terminal somewhere, and then pumped into the ship, right, for its bunker fuel to burn as it moves around the planet. That oil and gas company needs to be able to trace that movement of that product across that value chain into the tanker, and to be able to account for the emissions associated with that. So the ability to do that track and trace is critical. That's a greenhouse gas emissions one, but whether it's for particular product, mined product, whether it's metals or diamonds or any type of track and trace requirements as it moves through the value chain, blockchain is a very good application for that. Okay, lastly, I'm going to wrap it up now. So what does it take? As I mentioned, we're a platform, and it's already existing. We built our own blockchain because we needed to store lots of data and information on chain. So it's really just onboarding to the platform. It's finding a counterparty, picking a particular contract or application that you want to do this on. More than likely, we probably already have the template of that type of transaction built. You can begin to start with that, modify it as needed. The big lift here is actually getting the data, getting permission to get the data. Where are we going to get the data? Do the parties agree on the data sources? And so how we sort of get over that hurdle is we do number 4 here on the list. We said, let's just get some historical data to get started and to get it into the contract and run it. And then while we're getting the automated data, acquisition established, so that we can run the smart contract in real time. And usually we run the smart contract in parallel to current processes for a period of time, and then it gets turned on and goes into full production. So we typically can do this with a fairly straightforward contract in 2 to 3 months. We've done it actually through that bullet 4 there of testing with historical data. We've done it in as little as 4 days because we were able to adapt the smart contract very quickly. The customer just gave us a ton of, here's the historical data. Can you prove to us that this works? And then we were able to do that. But more complex contracts like that integrated, drilling well services that I mentioned, it takes a bit longer, more in probably in the 6-month range, 6 to 8 months. But then once it's done, it's done. You've got the template, the type of data that you need, and you're able to move it forward quickly and reuse it across your portfolio of contracts. All right. With that, I'll leave you with a few things to think about. As I've mentioned, it's not about, I had a friend that said, it's not about the shark. It's not about the blockchain. It's really about value. Can you deliver value? And if you look back to the origins, statement I made at the beginning of the talk, that's really how DataGumbo was founded. It wasn't, a hammer looking for a nail. It wasn't, a technology trying to find a problem. There was an existing problem. And Andrew, the light bulb went off and he connected some technologies that I think this might work. So we've approached it from that way. So it's always been about value for us. This isn't new technology. It's tested, it's proven. We're past the proof of concept, the proofs of value. We're in actual, use cases doing this. The hurdle to get started, as I just hopefully communicated, is pretty low, right? And the way is agile. You don't have to start big bang. You can start with a single contract, with a single counterparty, and get some experience under your belt and get going. And then can take a programmatic approach to figure out how you're going to roll this out and begin to automate all of your contracts. To be successful, you have to shift your thinking. It's about the data. If you think about a lot of our workflows around invoicing and things like that we do today, it's still paper-based. Yeah, we have SAP and Oracle ERP and other workflow type systems, but they're still what I would call paper-based processes that require a human being to come in and touch and verify and sign off and connect and so forth. Now that we've got, if we think it in a data way, what we're seeing is there's companies now that are wanting to say, we need to go back and look at our contracts and restructure them to be more verifiable using data and have them work that way. So data is the key to success, and it's not big data, it's specific data. What are the trigger events? How do I measure that I got, that I'm delivering what I promised and I'm receiving what I paid for, and apply the appropriate, commercial conditions. The other thing that we found is that just the smart contract is not enough. This needs to be part of a larger overall digitalization strategy. And how does it fit into that? Because if you look at the components of digital transformation, we touch maybe, typically there's about 9 of those. We touch about 3. There's bigger things to do than just what we do, but certainly we help, and we may help fund some of those other initiatives because of the benefits and the savings that get delivered through automating smart contracts. And then lastly, it requires a mental shift. I've talked about, what we find is people are still, adhering to those paper-based processes with some automated workflow. And what we're talking about here is really moving to data and to the ability to use that IoT platform, all these data sources to verify, things that have happened, whether it's ESG emissions, whether it's you delivered what you said you were going to deliver, or that this particular product is actually what I say it is, right? So those 3 main things. And so once you do that and have that mental shift and your organization is bought into that, we're seeing then, the uptake and the deployment of smart contracts across an organization really takes hold. And with that, Tanya, that's what I've got for today. I went probably maybe a little bit over, but
no, that's fantastic, Michael. It's really kind of all encompassing. You kind of covered all the bases. So thank you very, very much. Certainly a lot of things ring very, true to me. How